Stars are celestial bodies that emit their own light, thanks to the nuclear fusion that occurs in their cores. They vary in size, color, temperature, luminosity, and mass. There are several types of stars, but the main categories are white dwarfs. They are stars that have lived a long time and are now at the end of their lives. They are the remains of stars that were not large enough to explode in supernovae, but that lost their outer layers in a planetary nebula. They are very small but very dense and warm. They are about half the mass of the Sun, but just a little more than the size of Earth. White dwarfs no longer produce energy through nuclear fusion like normal stars. They just glow with the warmth left over from their old life. Therefore, they cool slowly over billions of years. They are so old that some of them may be older than the universe. White dwarfs are very interesting to astronomers because they reveal information about the evolution of stars and the history of the universe. They may also have planets around them, which could be places for life. Some white dwarfs can even merge with other stars or white dwarfs and cause powerful explosions called novae or type Ia supernovae. These explosions are used to measure distances in space and the expansion of the universe. White dwarfs are therefore fascinating objects, showing that even the oldest and faintest stars can have cosmic importance. They are silent witnesses to the greatness and beauty of the universe. Have you ever heard of brown dwarfs? They are celestial objects that are neither stars nor planets, but something in between. They have more mass than a giant planet like Jupiter, but not enough to initiate nuclear hydrogen fusion in their cores as stars do. Therefore, they are called failed stars, as they never shine like true stars. Brown dwarfs are very difficult to observe because they emit little light, especially in the infrared. They are also very cold, with temperatures between 500 and 3000 K, much lower than that of stars. They come in varying colors depending on their temperature and composition, but none of them are truly brown. The hottest ones can be orange or red, while the coldest ones can be magenta or blue. Brown dwarfs are fascinating objects because they help us better understand the formation and evolution of stars and planets. They may also have planetary systems around them which may harbor exotic life forms. Some brown dwarfs can even merge with other brown dwarfs or stars and cause explosive phenomena such as novae or type Ia supernovae. These explosions are used to measure distances and the expansion of the universe. Brown dwarfs are therefore mysterious and intriguing objects, which show that the universe is much more diverse and complex than we can imagine. They are the missing links between the stars and the planets. Have you ever wondered what happens to stars when they get old? Some of them turn into red giants, which are huge and bright stars, but also very cold and unstable. Red giants form when low or intermediate mass stars like our Sun consume all the hydrogen in their cores. Without this fuel, internal pressure decreases and gravity causes the core to contract. This increases the temperature and pressure and causes the remaining hydrogen in the layer around the nucleus to begin to fuse into helium. This process releases a lot of energy, which pushes the outer layer of the star outward, causing it to expand and cool. Red giants can have up to 100 times the radius of the Sun, but only between 0.3 and 8 times its mass. They have surface temperatures between 3000 and 4000 K, which give them reddish or orange colors. They are very luminous, being able to have up to 3000 times the luminosity of the Sun. They are also very variable as they undergo pulsations and constantly lose mass, forming nebulae around them. Red giants are very important to astronomers because they reveal information about the evolution of stars and the history of the universe. They may also have planets around them, but they are unlikely to survive the expansion of the star. Some red giants can even merge with other stars or white dwarfs and cause powerful explosions called novae or type Ia supernovae. These explosions are used to measure distances and the expansion of the universe. Red giants are therefore fascinating objects, showing that even the oldest and coolest stars can have cosmic importance. They are silent witnesses to the greatness and beauty of the universe. Have you ever wondered which are the brightest and most powerful stars in the universe? They are blue supergiants, which are gigantic and hot stars that live for a short time and die spectacularly. They are found in the upper left corner of the Hertzsprung-Russell diagram, which shows the relationship between the temperature and luminosity of stars. Blue supergiants form from high-mass stars, which are at least 10 times the mass of the Sun and can reach up to 100 times or more. These stars consume their hydrogen nuclear fuel very quickly, in just a few million years, and become very hot and luminous. They have surface temperatures between 20,000 and 50,000 K, which give them bluish or bluish-white colors. They have luminosities between 10,000 and 1,000,000 times the luminosity of the Sun, which makes them visible from great distances. They also have radii between 30 and 1,000 times the radius of the Sun, making them very large, but not as large as red supergiants. Blue supergiants are evolved stars that have already left the main sequence, where most stars spend most of their lives. They are in an unstable phase where they can undergo drastic changes in their size, brightness, and temperature. Some of them become blue luminous variables, which are stars that periodically vary their brightness, sometimes violently. Others may become Wolf-Rayet stars, which are stars that lose their outer layers in intense stellar winds and show spectral lines of heavy elements. Blue supergiants have an explosive final fate, as they end their lives in supernovae, which are the biggest explosions in the universe. Supernovae release enormous amounts of energy and matter, which can illuminate an entire galaxy for a time. They also produce heavy elements such as iron, gold, and uranium, which are spread throughout space and incorporated into new stars and planets. Supernovae can also leave behind compact objects such as neutron stars or black holes. Blue supergiants are therefore fascinating objects which show the grandeur and beauty of the universe. They are the most extreme and impressive stars which teach us about the origin and evolution of stars and elements. Have you ever wondered what happens to the most massive stars in the universe when they die? They transform into neutron stars, which are super-dense astronomical objects with reduced dimensions, extremely hot and rotating at high speed. They are the result of a catastrophic explosion called a supernova, which destroys most of the star but leaves a small core intact. Neutron stars are made up of neutrons, which are subatomic particles without an electrical charge. This happens because gravity is so strong that it crushes the protons and electrons that existed in the star, causing them to merge into neutrons. These neutrons become so tightly packed that a teaspoon of matter from a neutron star would weigh billions of tons. Neutron stars have an average size that varies between 10 km and 30 km in diameter, but can be between 1.4 and 3 times the mass of the Sun. They have surface temperatures between 600,000 and 1,000 K, which give them colors bluish-white. They are very luminous and can emit electromagnetic radiation across the entire spectrum, from radio to gamma rays. They also rotate very quickly with a rotation period that can reach millionths of a second due to the conservation of angular momentum. Neutron stars are very interesting to astronomers because they reveal information about the extreme physics and evolution of stars. They may also have planetary systems around them, which could be places for life. Some neutron stars can even merge with other neutron stars or black holes and cause gravitational waves, which are disturbances in space-time. Neutron stars are therefore fascinating objects which show the grandeur and beauty of the universe. Have you ever wondered why some stars change brightness in the sky? They are variable stars, which are stars that show measurable variations in their luminosity on timescales that can range from seconds to centuries. These variations can be caused by several factors such as pulsations, eruptions, rotations, eclipses, or explosions. Some of them, such as Cepheids and Rr Lyrae stars, have a fixed relationship between their period of variation and their luminosity, which allows them to be used as indicators of distance in the universe. Others, such as novae and supernovae, are sources of heavy elements which are spread throughout space and incorporated into new stars and planets. Variable stars are classified into different types according to the causes and characteristics of their variations. Pulsating variables, these are stars that expand and contract their outer layers, causing periodic or semi-periodic variations in their luminosity. Examples: Cepheids, R-Lyrae-type stars, Delta Scuti-type stars, Mirror-type stars. Eruptive variables. These are stars that undergo eruptions or other violent processes in their atmospheres, causing irregular or semi-regular variations in their luminosity. Examples: T Tauri-type stars, RS Canum Venaticorum-type stars, R Coroni Borealis-type stars, U Geminorum-type stars. Rotational variables. These are stars that have a non-uniform distribution of brightness on their surface, causing regular variations in their luminosity as they rotate around their axis. Examples: by Draconis-type stars, Alpha 2 Canum Venaticorum-type stars, FK Comae Berenices-type stars. Cataclysmic or explosive variables. These are stars that undergo explosions or mass transfers in binary systems, causing sudden and intense variations in their luminosity. Examples: novae, recurring novae, supernovae, AM Hercules-type stars, Z Camelopardalis-type stars. Eclipsing variables. These are stars that are part of binary systems where one star passes in front of the other, causing regular variations in their luminosity due to the eclipse. Variable stars are therefore fascinating objects which show the dynamics and diversity of the universe. If you want to see more content like this, don't forget to subscribe to the channel, leave a like and activate the notification bell. This way you stay up to date with all the news and don't miss any videos. Also, take the opportunity to share the video with your friends and leave your comment saying what you thought.